Hi, I am Gabriele Libardi, and today I'm going to be presenting the topic of my PhD. In my PhD, I focus on the Abstraction and Reasoning challenge, or ARC for short. This is a challenge in which there is a data set with different tasks, and each task is composed by approximately four input-output pairs of images, and the task of the AI system is to infer the role or that underlies transformation from the input image to the output image, and then to apply this role to the fourth input image to get the fourth output image. We try to cast this problem or to solve this problem using program synthesis. That means that we express these roles that the AI system has to infer as programs, and then we try to find these programs. Here are some interesting properties of the ARC dataset. And that is that these grids or these images are not, the content of these images cannot be anything, but has to be limited to certain tasks, such as arithmetic tasks or recognizing objects, geometry, and so on. What this challenge or this dataset tries to measure is developer-aware generalization, which means that the solution or these rules that underlie the transformation cannot be programs that the designer of the AI system is able to anticipate and then incorporate into the AI system itself. These have to be roles that kind of surprise the AI or the designer of the AI system as well. And the assumption here is that intelligence is connected to data efficiency, and that's why in all of these tasks, the rules that we try to infer, we need to infer them only from few samples. And there's a reason why deep learning and symbolic solvers all struggles on the ARC challenge. The first step to tackle the ARC challenge is to design a domain-specific language that is tailor-made for the ARC challenge. Here on the left, you have an example of a program expressed in this domain-specific language. A program in this DSL is a sequence or is composed by many different statements or instructions. Here you can see different instructions on different lines, and each instruction is made of one function and different arguments. These allow us to only generate programs that are well-typed and only produce images as output. We can then combine these programs and with the input-output images, and then feed them to a neural network that's been previously trained. And the neural network should give us a score of how likely is the program to represent the role that underlies transformation from the input to the output images. We then use this score together with our search algorithms such as beam search or A*, to search for the real program, the program that underlies this transformation. Here are some preliminary results. Here are some tasks from the ARC challenge that this system, this hybrid neural network and symbolic system is able to solve. And these are tasks where, like a naive breadth-first search would otherwise fail because the programs that express these transformations are too long. These are some promising results, but it's by no means the end of the story, and there's much work to be done in the future. Thank you for your attention.